Hello everyone, my name is Jesse Oldham and I'd like to welcome you to today's webinar where we'll discuss how to optimize your drilling program. Our presenter today is Paul Richardson. Paul is a senior geologist with our technical services team and provides technical support, training, and consulting services in the North American region. Paul has over 15 years experience at various gold operations in the Western US in roles ranging from grade control to resource estimation. And with that, I'll now hand it over to Paul.
Thank you, Jesse. Hey, we're excited to show you one of our latest developments, the Vulcan Drillhole Optimiser, or DHO as it's sometimes called. For anyone who's done drill hole planning, it can be long and tedious. It starts by identifying targets. Maybe it's to upgrade the classification in your resource model and requires drilling to a specified drill hole spacing, or maybe it is to de-risk your model by targeting the areas of the most uncertainty or the highest grades. Once you've identified targets, you still need to decide where to drill from, and you need to be sure that you're using drill angles that are realistic for the type of drilling being done, whether it is from surface or underground. How do you know what hole to drill first? How much will it cost? How long will it take to complete your program? What if your budget's cut? What if someone else designs a plan and it looks completely different from yours? And what if you're no longer able to drill from your preferred paths? How do you know you are targeting the best areas? The Drillhole Optimiser can take the guesswork out of drilling using available data to develop better plans in less time. So here's our agenda for today. First, we'll start off by defining just what is the Drillhole Optimiser. Then I'll describe who's it for, who's it not for, and illustrate a few examples of the outputs. We'll describe how it works, and then we'll jump into a live demo and I'll walk through each of the panels and explain them. We'll wrap up with a summary, and then with the remaining time, we'll open it up to questions. So what is the Drillhole Optimiser? The Drillhole Optimiser, or DHO, is a tool to help geologists and even engineers plan infill drill programs. It uses a powerful genetic algorithm developed by Resource Modeling Solutions to target drill holes using a variety of criteria to meet multiple budget scenarios. Think of it as having 1,000 geologists doing drill plans and then getting them all to agree. We've taken the RMS engine and integrated it with all the Vulcan functionality that you're familiar with. In addition to creating optimized drill holes, you can compare the costs to existing plans. The power comes from being able to test thousands to millions of hole configurations to maximize the impact of the program while minimizing the cost. In addition, it is a standard Vulcan add-on module that you can tack on to any existing modules that you have. So who's it for? It's for exploration, production, and resource geologists. But at mines that are short-staffed, an engineer could easily work their way through it. The program relies on a block model for targeting areas of interest, so it's best suited for advanced exploration, development, and production stages of mining. It can be used for both open pit and underground deposits, and it was designed for infill drill programs intended to upgrade classification or decrease risk. It can be used for RC grade control programs, and it is especially useful for evaluating multiple areas across the mine to determine what drill programs will have the greatest impact using a given budget. Who's it not for? Because the optimizer is seeking the most efficient way to drill blocks, it is not ideal for traditional grid or fan drilling, although it can be adjusted to focus primarily on achieving a desired hole spacing. It is not for drill and blast or greenfields exploration where there's not a block model. For these types of scenarios, Vulcan has other tools such as blast and ring design and the current drill planning tools. We are in the process of a significant update to our drill planning tools, and they will complement the DHO outputs nicely. If you're interested in learning more about other drill planning tools, please send us a message down in the chat. So let's take a look at a few examples of outputs from the optimizer. First, I'd like to show you examples created by DHO, and then I'll explain the panels and what it takes to run it. In this example, We ran DHO on a large open pit using budgets of 500,000, 750,000, and 1 million. The tan surface is the topo. The gray solid represents the volume of blocks that meets the desired drill hole spacing, and the colored solids are the volume of blocks that are upgraded from the optimized holes. The Drillhole Optimiser outputs layers into Vulkan for each budget. In addition to the layers, CSV files for each budget are saved to a scenario-specific folder. In addition to the solids and the Vulkan layers, there are graphical outputs that show you your budget spent compared to the amount of footage or meterage drilled and the percent converted of the available blocks and the converted resource. The Drillhole Optimiser can help you avoid drilling underground development. In this case, the declines are avoided because they pose a significant health risk. Drillhole Optimiser can be adapted to help create wedge holes in case it's too costly to drill everything from the surface. The CSV outputs contain all the information needed to populate a proper drill hole schedule. For each hole, you have the collar coordinates, the azimuth, dip, the total length. If it happens to use a pre-collar rig, then you'll have the RC portion of the hole and the core tail. In addition to the hole parameters, you have the cost of the hole, the relative uplift, which is a quantifiable number that helps you decide the total impact that hole will have in relation to other holes, and then the duration or the amount of days it will take to complete the hole is also calculated. There's also a summary of all the holes drilled on each drill pad. In this example, I've color-coded the total cost, the total relative uplift, and the uplift by cost to help me prioritize which pads I want to drill first. So how does the optimizer work? Basically, first it identifies blocks that meet the drill hole spacing or classification requirements using the existing holes. Then it removes those blocks, making them not available to the optimizer. It groups the remaining blocks into target nodes, and then it optimizes the hole placement to intercept as many target nodes as possible, honoring all of the conditions and the limits, using literally thousands to millions of hole configurations. Then it orders and ranks holes to honor geologic trends and retains holes with the maximum impact for the minimum budget. So let's get to a live walkthrough. Let me switch over to Vulkan. In this view, we're looking down in plan on my project area. I have a topo loaded. I've digitized polylines for roads and points for potential places I could build a drill pad. Below the topo, you can see my existing drilling, an underground decline that I can use to drill from, and my target domains in the colored solids. The Drillhole Optimiser is located in the menu bar underneath Geology, Drillhole Optimiser, and there are two components to it. The first is the drill rig library, the second, the Drillhole Optimiser editor. We'll look at the library first. Here in the library, which is unique to Vulkan's Drillhole Optimiser offering, you can create a list of all the available drill rig types that you can apply and use in the optimizer. It's all user-defined and customizable. You set the rig rates, you specify whether it's for pre-collar use or if it is going to use a pre-collar. For example, this surface core hole is specifying it's going to use a surface RC hole for pre-collaring. These visual dials help you see at a quick glance the available directions that you're letting it drill and the limits that you're applying. You specify the depth that the drill can go and apply specific cost parameters for setup and as the cost changes with depth. Once you have this set up, you're ready to move on to the next step. The Drillhole Optimiser editor. There are several panels that can be filled in here. This will look familiar to those who've used Vulkan, where we're using a specification file to save all of the parameters, and within each specification file you can have multiple scenario IDs. This helps you organize your workflow. Some of the files that are required to run the Drillhole Optimiser is you need to have a samples database. If you want to apply any specific types of filters to exclude some samples, you can using this database filter. The optimizer relies on a block model. This can be a regular block model or a sub-block model. And you can also apply filters and conditions to limit the blocks that you are targeting the optimizer on. Then you choose what you want to optimize by. By default, the optimizer is set up to calculate metal. So when you specify a grade variable and a density, it will calculate the metal equivalent of that. Specify a cutoff, and it will only target those blocks above that particular cutoff. If you want to be more flexible, you can use any variable in the block model. And the way the optimizer works is it doesn't have to be a grade, it's just looking for the highest value blocks. So this is where you could put in a recoverable gold variable, or you could calculate your own type of variable, which might be gold times distance to the nearest drill hole. That might help you seek out those areas of highest risk. We're going to stick with metal calculation. Some of the other optional inputs are domain, drill exclusion, and classification. If your deposit has multiple domains, in this example, I've got 4 high angle intrusive domains, so I'm using the domain variable. This could also apply to different regions of the model that have different desired drill hole spacings. The drill exclusion option allows me to avoid drilling blocks. In this case, I've coded the underground declines into my model, and they have a value of 1. And so I'm going to avoid drilling through any block that has a value of 1. Another option is to use the existing classification within the block model. So if I'm already satisfied with my drill spacing and measured and indicated, but I want to target my inferred Cat 4 and Cat 5 blocks, then I move them to the right and make them available for drilling. Another option is the topography. By including a topo surface, you will prevent any underground holes from drilling up through the topo, and any polylines or points that you're using for potential pad locations will all be registered down to the topo. Drill pads and locations. Drill pads. Similar to the drill rig library, where we specify various constraints and parameters for each drill rig, we do the same thing for the pad types. So in this example, I have surface pads, which are represented by my magenta points. I can allow up to 10 holes to be drilled from any one pad, and I don't want my pads to be any closer than 30 meters to each other. I also assign a base construction cost. In addition to the construction cost, I can select what drill rigs I want to use from my drill rig library. I can choose as many rigs as I like, and the optimizer will choose the one that best suits the situation. In this example, I'm using the surface core that's tied to an RC pre-collar. I also have parameters for a decline. You'll notice my decline didn't have any drill bays on it, so I've added a significant construction cost to construct a drill bay. And in this one, I am using an underground core rig. And then I have roads. and the cost is less, but I might need to dig a sump or something for the muds. With polylines, instead of having a single point where the Drillhole Optimizer can choose to create a pad, it will find a point anywhere along this polyline, but I've specified that I don't want them to be any more than 100 meters, any closer than 100 meters. Once you have these defined, then you can pick and choose what layers to load into that can be used for pad locations. You also have an option to apply an additional location cost. For example, if you're using active haul roads, you might apply a location cost to those roads because they are in areas of high traffic. The location cost can act as a penalizer cost to make it look less desirable to the optimizer. Another great feature about the Drillhole Optimizer is it will optimize drill holes for you, but if you have an existing plan, you can select that layer and it will pull in the information. You assign the pad types, the rig types, and it will cost it for you. And then you can compare a planned drill hole program to your optimized programs. Under the classification tab, this is where you define your desired drill hole spacing. So for each of my domains, my mineralized domains are 1 through 4, and then the blocks outside of them were domain 0. I'm going to require 3 drill holes with a maximum average spacing of 30 meters and a maximum search of 50. By checking the soft boundaries, I can let the hole see from one domain to the next. An important feature of the Drillhole Optimizer and any drill program is to define the geologic trend. Because the optimizer targets the highest grade values or the highest values and accumulates them, it would naturally want to drill straight down high angle structures. But that isn't the best direction. It's not representative. And so we define a geologic trend. I can move and rotate this interactive ellipsoid, align it with my ore body, and then the blue line coming out of it is my preferred drilling direction. And I can set that for each of my geologic domains. Also, depending on the type of mineralization, I can assign a strength to it. In this case, where I have high angle, thin, narrow ore bodies, I'm using moderate to strong. If your grades are more disseminated, you can use a weaker strength or none at all. Under the optimization tab, there's a lot of different parameters. The first one is a specific type of classification that is separate from your resource classification. It is the classification that is defined by the existing drill holes using the parameters defined in the classification panel. So this maximum average distance of 30 meters. So it will code all the blocks that meet this criteria using the existing drill holes. Using the handy budget generator right here, we can fill our budget grid with multiple scenarios, and we can custom name each of the prefixes and the output variables, as well as modifying the color. If the variables don't exist in the block model, they'll be created on the fly, and we can generate grade shells of the blocks that were uplifted, as you saw in the previous examples. Some of the constraint settings, because this is an optimization, the longer it runs, the more optimal your results will be. We recommend starting at 15 minutes, but for testing purposes, you could use less. And then when you have it set up the way that you like, then you can put in and let it run overnight or for a few hours. In this example, I'm also using a pre-color domain. So I'm pre-coloring anything that's outside of my domains 1, 2, 3, and 4. Our outputs are saved into a working folder that's named after the scenario ID, and the Vulkan layers that are generated are also prefixed with the scenario ID to help keep everything organized. So how do the results look? This is the result from our $1 million budget. Here's our $2 million results, 3 million, and then might as well just jump to 10 million because, hey, it's just money. But you can see how each of these change. This gives you a lot of different options to go through and choose and refine your drill programs. In addition to the output solids and the layers, each polyline has all of the information stored in templated attributes, which makes it very easy to pull into our Vulcan Gantt scheduler or other scheduling tools. All of our resulting files are stored into a directory named after the scenario ID. I have my triangulations, my CSVs, some of the graphs that are generated. Let's take a quick look at the Excel file. So here's all the holes. I have my relative uplift, the cost, how long it will take. For the pads, I can go through and I won't worry about that. You can sum up the number of days. In this case, I can see that this is going to take 287 days to drill. That's a long time. I might need to use more than one rig to complete my drill program in a decent amount of time. So hopefully this gives you a quick idea, a good feel of what the Drillhole Optimizer can offer you. Let's come back to the PowerPoint and kind of wrap things up. So the Drillhole Optimizer, it's data-driven. There's so much information stored in your block model, and you have various drill rig constraints and costs, underground workings to avoid. It takes all of this into consideration. Basically, it reframes how we do drill hole planning. So instead of worrying about the mechanics of placing the hole, we focus more on our goals and our objectives and the parameters to obtain the optimal result. It's a lot like using pit optimization. We wouldn't expect engineers to optimize a pit by hand. There's just too much information, too many things to consider. And so this tool helps geologists to work smarter, using all of the available data to evaluate more possibilities in less time. It can help you be more effective by reviewing multiple budgets and scenarios and comparing existing plans to optimized ones. And it will help you prioritize and sequence holes and drill pads using quantitative results. So what makes the Drillhole Optimizer unique compared to other offerings? One, it's integrated with all of the existing Vulcan tools. There's no scripting needed, no file conversions, no importing and exporting of files. The classification results are stored back into the block model for a more detailed analysis if you wanted to use advanced reserves. The outputs are further enhanced by using the existing drill planning tools, where you can now apply downhole deviation or adjust and lengthen the holes. The drill rig library is unique to Vulcan's Drillhole Optimizer, allows you to collaborate with other geos on your site. And lastly, you have full control of your data. There's no need to send it off to a third party. This is your program, and you run it as often and whenever you feel like you need to. The power is that just by reducing one unnecessary hole, it will pay for the module over and over. So I encourage you to consider and look into the Drillhole Optimizer. Jesse, I'll turn it back to you and we can open this up for some questions.
Yeah, thanks very much, Paul. We do have just a couple of minutes for some questions. So as a reminder, if you have any that you'd like to submit, please write in your questions in the panel on the right-hand side of your screen. Let's take a look to see if we've got any so far. Let's see, Paul, how accurate is the relative uplift?
Good question, Jesse. The relative uplift, it's called relative for a reason. It's a representation of the impact of that drill hole, but it's not a number that I would hang my hat on. But it does let you quantify and show which holes are better than others. Good question.
Okay. Let's see. Can I use DHO to plan dewatering holes?
Yeah, if you have flow in your block model, then maybe you can target the areas of highest flow or where you have high permeability and high porosity. You just need, you would use the alternate variable instead of a metal output.
Excellent. Thanks, Paul. So we're pretty close to our time here today. If we didn't get to your question, we will circle up with you individually and make sure that we answer those questions for you. So if you have any additional questions or you're interested in more information on DHO, please feel free to contact Paul or myself directly, or you can email support@maptek.com. But on behalf of the entire Maptek team, thank you for attending, and we hope you have a great day.